Good morning, dear student. In today's lecture, we are very much interested in the pictorial representation of pure vital interactions for cyclic pi system or cyclic ligands. So, if you consider the cyclic system, the procedure for obtaining the pictorial representation of the orbitals of cyclic pi system is similar to the procedure for linear system. So the procedure is same, but in this cyclic pi system there is a slight modification that we discuss in this today's lecture. Let us discuss the first one. The smallest cyclic hydrocarbon is cyclo C3H3 radical. C3H3 radical. And if you see the structure of this is like this. So there should be a double bonds. One hydrogen should be there. One hydrogen should be there. So carbon 3 and hydrogen is also 3, and there should be one radical. So this is cyclo C3H3 radical. So this is the system. For this cyclic pi system, we discuss the pictorial representations. So we are very much familiar that the lowest energy pi molecular orbital is formed by the overlapping of each 2p orbital of every carbon. So the lowest energy pi orbitals, because there is a pi bond, so therefore the formation of pi molecular orbital is resulting from the constructive interaction between each 2p orbital of the ring. So every p orbital of each carbon involved in bonding, which results into the pi molecular orbital. So this is the first case, that is we get this. All three p orbitals are involved. All three p orbitals in same phase, and therefore uh, the two electron goes here. So if you consider these C3H3 radicals, so total 3 electron is there. So this pi bond containing 2 electrons and there is one radical, so total 3 electron is there. In cyclic C3H3 radical, total 3 electron is there. Out of that, the molecular orbital, that is pi molecular orbital, which is formed by the constructive overlapping of each 2p orbital in the ring, again 2 electrons. So only one electron is remain. The second one, this is your psi 1. Let us consider it is a psi 1, that is the function psi 1, and the second one, that is psi 2. But in this case, if you consider psi 2 consists of one node, and if we draw the structure of this psi 2, so in this cyclic system you should remember that is each function having a same number of node, or the molecular orbital having a same number of node have equal energy. The energy is same, that is you should remember the important point is that uh, the energy, that is the if there is a same node on every function, that is if you consider no doubt there is a 3 carbon atoms, so total 3 wave function is there, psi 1 psi 2 psi 3. But if you consider psi 2, there is a one node, and if you consider psi 3 for this C3H3 radical, there is also one node, and therefore the energy of these both wave function, that is psi 2 and psi 3, is same. It is not different, they are equal energy. So you should keep in mind, this is only for the cyclic pi system. That is, if you consider the psi 2, in this case if you consider the psi 2, so there should be one node. So how the one node is possible? That is the third carbon, it is not involved in the bonding. We can consider the middle carbon, that is a node is present. So if you consider this is the system, so this is the node which bisects the molecule, and only this carbon, this p orbital of carbon and this p orbital of carbon involve in bonding. It is not involved in bonding, it is a node. Therefore I will make a mistake here, that is both this p orbital in different phase, both this p orbital in different phase. So they are not in same phase, they are different phase, there is a node. So only 2p orbital is there. Only if you consider the numbering, carbon number, this is 1, this is 2, and this is 3. So only the p orbital of carbon number 1 and carbon number 3 are involved in antibonding interactions, and the second carbon p orbital does not involve because it is act as a node. So there is a one node, so the no electron density is there. So if you consider the energy, if you consider the electron, that is non-bonding electron, it is not a bonding interactions. Okay, it is not a bonding interaction, so the one electron is goes into this. And if you consider the third one, that is, this is very simple nodal representation, that is the node is present. If you consider this molecule has a plane and this node bisects the molecule, that is the node is perpendicular to the plane of the molecule. So if you consider this is the plane, this is the plane of the molecule, then this node, it is perpendicular to the plane of the molecule. Similarly, if you consider the another pictorial representation, that is if you consider this system, there is another node is also present which bisects the molecule, not symmetrically, but it bisects the molecule, and this node, it is also perpendicular to the plane of the molecule, and therefore there is a node and there is a one node. So this wave function is also having one node, and this wave function is also having one node, and therefore they are equal energy, therefore they are equal energy. So if you see its pictorial representation, how this node is occur, that is the two p orbital in same phase, but the third p orbital is in a different phase. The third p orbital is in different phase, and both this having, so if you consider this is the nodal plane, so in this case also this wave function is also consist of one node, and this wave function is also consist of one node, and therefore the energy of this pi orbital, pi molecular orbital is same, because they have same number of nodes, and therefore if you consider the C3H3 radicals, so the number of molecular orbital which is equal to the number of atomic orbitals. So in this case, this is the bonding molecular orbital, and there is a 3 atomic orbitals, and therefore we required 2 molecular orbitals. So if you consider this, this is the first, this is the second, both these having one node. So this is the node which bisects the molecule into two equal half, but this node, it is perpendicular to the plane of the molecule, and it also bisects the molecule, and therefore both these wave function have same energy, and they have, both this wave function have same number of nodes, and they have same energy. So this is the representation for the C3H3 radical. So you should keep in mind, so this is the relative energy. Why these two wave function, that is psi 2 psi 3, have same energy? Because they contain same number of nodes. So if you consider this is for C3H3 radicals, this is for C3 H3 radicals. So let's discuss the another example, that is the next one, that is your cyclobutadiene. cyclobutadiene cyclobutadiene uh, if you consider this cyclobutadiene, then uh, a simple way to determine the p orbital interactions and the relative energy in the case of cyclic pi system for regular polyns is to draw the polyns with one vertex pointed down, so we can draw this cyclobutadiene in such a way that one vertex down, one vertex down, and each vertex then corresponds to the relative energy of the molecular orbital. So it is very simple. So this every vertex, it is corresponds to the relative energy of that molecule, relative energy of the molecular orbital. Okay, and the number of nodal planes perpendicular to the plane of the molecule increases as one goes to higher energy. That is, so you should keep in mind whenever we consider acyclic polyns, and you should draw in such a way that each vertex, that is to draw the polyns in such a way that one vertex is pointed down and each vertex is corresponds to the relative energy of the molecular orbit. So if you consider, this is the energy, this is the relative energy. So if you consider this cyclobutadiene, it is like this is your psi 1, psi 2, psi 3 is there, and psi 4 is there because it contains 4 carbon. So if you consider this is your cyclobutadiene, it contains total 4 pi electrons. So if you consider its electron, then 2 electron is goes here, 1 electron is here, 1 electron is here, because if you consider this psi 2 and psi 3, they having one node, and one node means the electron density. This is not a bonding interaction, so only one electron is there, only one electron there, both having same energy because they contain one node. And this psi 4, it having a two nodes, so its energy is different from psi 2 and psi 3. So how uh, these nodes are possible in this cyclobutadiene, let's discuss it. If you consider the first one, that is your bonding interaction, so this is the energy, that is bonding molecular orbital, bonding pi molecular orbital. So if you consider, this is the system. In this system, that is bonding pi bonding molecular orbital, all p orbital in same phase, all p orbital all p orbital in same phase. So this is your psi 1, so this is your psi 1, we can consider. This is psi 2, psi 3, and psi 4. So why psi 2 and psi 3 have same energy? Because they having the same number of nodes. Because whenever we consider cyclic polyns, so you should draw in a such a way that the polyns with one vertex is pointed down, and each vertex then corresponds to the relative energy of molecular orbital. So for cyclobutadiene, psi 1 is there, that is bonding molecular orbital. Then psi 2, psi 3 having same energy, and psi 4, it is having no electron is there. So it is your, if you consider, they having different energy because it has two nodes. In this case, the psi 4 having two nodes should be there. So we are not considering because they having the same energy, so we can write only a psi 2 is there, and the last one is considered as a psi 3. So for cyclic system, one wave function is less than the number of carbon atom, because both these wave function having same energy, so we can consider it is only as psi 2, and the next one is considered as a psi 3. So this is your psi 1, that is all p orbital in same phase. And if you consider the second one, that is psi 2, so how this psi 2 is there? Because it having a one node, So how this node is possible? We can write this as, so this is your polyns, and if you consider only 2p orbitals involved in molecular orbitals, because they are in different phase and there is a one node should be there. So two carbon two carbon atom of this cyclobutadiene involved in node. So the electron density, they are not involved in the molecular orbital formations. Only 2p orbital of two carbon atoms are involved. Only this carbon and this carbon involved in pi bond, involved in pi molecular orbital formation, and this carbon and this carbon, they are the part of the node, and therefore they are considered as a site. If you consider the another orientation for this system, that is how the second first node is, this system consists of one node, so one node should be there, this having a zero node. So this is our side 2, but side 2 is also having, that is it also having another representation. That is, if you consider this system, if you consider this system, then the node like this, that is the node like this is the node, because this is also one node, this is also one node, and therefore they are having a same energy and they are considered as a site. So if you consider, there should be a node, it indicate, if you see this presentation, if you consider this presentation, there should be a node, means this is your positive, this is your negative is there, again is there, here also there should be, if you consider, and there should be like this, there should be a node should be there. So this is the representation for site. So two pictorial representation is possible, and both having one node, and therefore both having one node, and therefore the energy is same. And if you consider the next one, that is uh, your psi 3, that is it consists of two nodes should be there, there should be a two node should be there. So we consider this as, I will make mistake here, because for our convenient we consider it as psi 3, psi 2. Okay, it is, let us consider it is psi 2 and this is your psi 3, because psi 2 consists of one node and psi 3 consists of two nodes should be there. So this is your psi 1, so it consists of zero node. This is your psi 2, means it has a one node, so this representation also having one node, this representation is also having one node should be there. And psi 3, so psi 3 it indicate the number of nodes, that is wave function minus 1, so it consists of two nodes. So how these two nodes is possible? If you consider how the two node is possible, then this is the case, how this two node is possible. You can write this as, and this is your p orbital of each carbon atom, and there is psi 3. So psi 3 having two nodes, two nodes is what we like, we draw like this. So this is the node which passes from this two carbon, that is, if you consider this carbon number 1 2 3 and 4, so the node passes from carbon number 2 and carbon number 4. This is one node should be there. Okay, this is one node should be there, and the second one, that is like this, the node, it bisects this molecule into two equal halves, the node which bisects the molecule into two equal half. So this is the representation for this psi 3, this is the representation for psi 3. So this is for cyclobutadiene, this is for cyclobutadiene. Then if you consider, this is for cyclobutadiene, that is the node passes from carbon number 2 and 4 is there, and the next one, that is the node that is which is perpendicular to the plane of the molecule, and it bisects the molecule into two equal half, and this is your psi 3 for this cyclobutadiene. So you should remember the psi 1, it is the bonding molecular orbital. Every p orbitals are involved in pi bond formation. And then if you consider the second, that is psi 2, psi 2 having a one node should be there, and one node having a two pictorial representation. So it having the energy is same for this two pictorial representation because they are having only one nodes. They are equal energy, and the psi 3 consists of two nodes. So the nodes passing from carbon number 2 and carbon number 4, and the node which is perpendicular to the plane of the molecule bisects the molecule into two equal half. So if you consider the energy, actual energy, this is your psi 1, then this is your psi 2, and this is your psi 3. So there is a total of 4 electron is there. So this is your 2 electron, that is bonding interaction is there, and this is your non-bonding interactions. This is your non-bonding interaction. So this psi 2, it is act as your homo, and this psi 3, it is act as your LUMO. Okay. So this is all about the cyclobutadiene. In next lecture, we discuss the remaining cyclic pi system, that is pictorial representation for remaining pi system. Thank you.